collecting information about those people that are viewing your billboard or people that are viewing your that are seeing your flyer. So look in that direction, for look in that direction for your business, when you if you plan to advertise your business or you try to promote your business. Now back to our question, and the question is that with enhancement in technology, companies are now using different ways for marketing their product and their services. The sensors are being used with new marketing campaigns, and this results in new type of data and information. So the question is, which element of big data is being discussed here? And I'll take the question again. With the elements of technology, companies are using different ways for marketing their product and services. The new sensors are being used with new marketing campaigns, and this results in new types of data and information. So which element of big data is being discussed here? Of course, the answer is there. So with sensors, of course, you get different varieties of data, and you get different type of information from this type of sensors or marketing campaigns that are thrown out there. Yeah, so if you have any question, please feel free to ask me. If you have any comment, if you need some clarification, I'll be glad to. Okay, Ekwi, please go
on. Okay, I was going to ask why variety is not the answer. Because when I read it at first, I was thinking variety. And even in your explanation, you mentioned variety.
Okay, so in my explanation, I said variety, Abby.
Yes, you said variety.
Yeah, okay. So the new sensor are being used. Okay, let me say this again. The sensors are being used with new marketing campaign, and this results in new type of data. If it's type, then it's variety. The answer should be variety. The answer is not velocity. There is nothing here that is indicates the rate at which the data is changing. When we talk about velocity, that means that is the rate of change. There's no rate of change here. So the answer is actually variety and not velocity. Are you confused?
I'm not confused. If the answer is variety, it's fine. But if the answer is velocity, I will be confused.
Okay, thank you. I think the answer is, I think it's a mistake there. The answer is actually variety, not velocity. When you talk about new types, when you talk about types, you're actually talking about different varieties of something. So let's so we'll get that fixed. We'll get that sorted, and so that it doesn't repeat in subsequent slides. Okay, so in terms of and thank you for pointing out that Ekwi, thanks a lot for pointing out that. So in terms of the different applications of big data, we can go on and on to discuss different applications of big data. I'm always very interested in talking about the different applications, and I'll just share my slide. Where is the slide? Yes, so I have a presentation here. I used this presentation yesterday with a client, and I'll just bring it up just to put it in context, and I'm sure you should be able to adapt it for your industry or wherever you work. I can see that a lot more people joined the class this afternoon. So depending on where you work, you should be able to adapt this to your own experience. So I'm sharing my screen and it's coming up. If you can see my screen, please let me know if you can see the screen. If you cannot see the screen, let me also know if you can't see it. So where is it? It's coming up. Yes. Okay, so I'm sure you can see my screen. Yeah, this is screen. This is not what I'm looking for. Yeah, this is what I'm looking for. Can you see my screen? Please, can you indicate if you can see my screen?
I can see your screen.
Okay, great. So this particular client was asking for octave analytics services. So they wanted to know the different areas for which they can apply um, analytics to the type of data they generate. So this is it's a telecom company, and yeah, it's a telecom company. So I just want to quickly run you guys through some of the different ways that big data analytics can be applied to this company. But however, it's also applicable to other industries that are not necessarily a telecom industry. So the first one here is what we call dormancy prediction. And if you look at a bank, for instance, at some point, if a customer does not generate transaction after a while, the customer becomes dormant. If you are on LinkedIn, maybe you are a LinkedIn user, you have your profile on LinkedIn, you can become dormant. If you're on Facebook, your account may also become dormant. There are some social media pages that will tell you that it's been a while. I think, yeah, Instagram at a point will tell you that it's blessing. It's been a while that we saw you. That can you catch up with the new thing that is happening on Instagram, and then they will show you the profile of some of your friends that are doing some stuff on Instagram. That comes like in an email. It comes to you in an email. So what they are trying to do is that they are trying to prevent you from going into a dormant state, you know. So then also in telco, it's also applicable in telco. They call it churn. If a customer does not use his phone over a period of 3 months, the customer goes from active state to inactive state and then into a dormant state. After a while, it goes into a pool and that number is recycled. It comes at a cost to the telecom company. So most of the time, while the customer is still very much active, some of those businesses would like to predict the propensity of the customer to become dormant. And if they can predict the propensity of a customer to become dormant, then they put some intervention in place in order to be able to win back the customer. It will come in form of incentive. They can give bonus to that customer just in a bid to win back the customer. So that's an application of big data in across different industries. So I've given you like 3 industries in one. There is this other one that is called customer link analytics. So you imagine a network, a telecom network that has a number of customers. Maybe that has like okay, Eric, you have a question, please feel free to ask your question. Eric, please ask your question.
Oh, I don't have a question. It was when you asked if I understand you.
I was wondering if you had a question.
Oh, sorry, I forgot to lower it.
Okay, so let's talk about customer link analytics and the applications of customer link analytics. So of course, almost everybody here will probably be on Facebook. At times you see, Facebook will tell you that, oh, at times Facebook recommends some people to you that this person is your friend, and this other person is a friend to your friend. No. So let me put that again. So customer link analytics. So at times you see some of those social media pages, they will tell you that they recommend people to you. They will tell you that you and this particular person, both of you have about 20 mutual friends, but both of you are not friends. So I'm a friend to like 20 different people. There's another guy, his name is Eric. He's a friend to like those 20 people, but I and Eric, we are not friends. So at times you see a platform like LinkedIn or Facebook will recommend that, will I want to befriend Eric? Because they have seen that on my profile, both of us share common friends. So it's likely that we have some things in common. How do you monetize this in the banking space? How do you monetize this in telco space if you work in those industries? I'll give you some applications of this. So in the telco space, there's what they call so it's like a graph. It's like a graph. So a telco, like say a telco has 20 million subscribers. Within those 20 million subscribers, there are going to be smaller networks of people that make up the 20 million network. So within the 20 million subscriber base, there are going to be like maybe 10 people here that call each other, another 20 people there that call each other, another 50 people there that call each other. Different network within the customer base of 20 million. Now, in each of those sub networks, there is going to be someone that is a leader, and there's going to be someone that is a follower within the network. So how the telco guys, how they monetize this is that they can identify the leader within the network and put a ringback tune on that leader's account. So at times you call some people and you're wondering, did this person actually download this ringback tune? So what they are trying to do is that they've identified that leader in the network and they give the person a ringback tune for free. So maybe the ringback tune is just 50 naira. So because they know that a lot of other people within the network are likely going to be calling this leader within the network, and they know that by the time you call that leader within the network, you hear things like, if you love this tune, press 1 to copy the tune, you know. So more or less, what they are doing is that they are marketing the ringback tune product by giving it out for free to one user that is a leader within the network. And the essence of that is to be able to leverage that user's network to distribute that product to other people within his network. And the interesting thing is that because it's a network, it is likely that everybody within that network, they share the same property with the leader of that network. So it's not just some random person that they are giving the ringback to, That is a way of leveraging customer link analytics. Then also in a bank of 10 million customer base, there are going to be people that, okay, we notice that money flows from this person to every other person within the network. There seems to be some sort of transaction within these different users. Is there a way that the bank itself can monetize this relationship between these different users to create products and services that will add more value to the bottom line of the bank? That's another classical application of customer link analytics. You have custom loyalty scoring model. Loyalty scoring model is for businesses. They need loyal customers, and those loyal customers are customers that's going to be like their promoters, that is going to tell other people about their product. And those customers themselves also use such product that they are selling. So you can talk about maybe a sweet sensation. There are people that consistently have their launch sweet sensation, even if you have maybe the place and Mr. Biggs and Tantalizers around the same place. They will just choose sweet sensation above every other place. That's a loyal customer. So when you continuously capture data on customer after a long period of time, at some point you should be able to determine out of all of your customer base who are the most loyal customer. So knowing the most loyal customer, you'll be able to now create incentives and services around those loyal customers. Those are some applications of big data. You have also. I'll take one more. I'll take one more. There is one that is called early high value detection model, and how that works is EVDH. How that works is that at the point which like businesses want to identify which of their customers is the most valuable customer at any point in time, or which of their customer is a premium customer. When you do the hierarchy of spend of customer, you likely realize that there are some 20% of your customers that actually spend like 80%, that generate 80% of the revenue. So it is good you identify those customers early at the beginning of the lifetime of that customer with your organization. So the early high value detection model, how it works is that it tries to identify, it tries to predict whether a customer is likely going to be one of those premium or high value customers, rather than you waiting for a very long time to determine that, oh, this customer is going to be a high value customer at inception. So it's just like you have a shop, for instance, and a customer walks into your shop and you want to tell that, oh, this person is actually a high value customer. This person is worth buying this volume of product from my company. The way you treat that customer will be different from somebody who is just going to buy a 5,000 naira product from your store. So that's another application. Then we have a variety of those different applications in device analytics, in network, digital network transformation model, capacity planning models, and so on. Social network analytics, geospatial analytics, customer profitability model. There are so many applications. There is almost no industry for which you cannot apply big data. There's almost no industry which you cannot apply big data. So I go back to my slide. Where's my slide? Yes. So just a minute. Please feel free if you have any question. Ask me any question. If there's something that is not clear, unmute your microphone and please ask your question. So my slide here. Big data can be relevant for social media influence. If you want to influence people on social media, of course, you must have heard about Cambridge Analytica, where this company, what they did was to influence the kind of news or the perception about a particular election candidate in order to be able to redirect those electorates, the people that are going to be casting their vote, now to be able to redirect them to cast their vote for another user. Although that led to the end of that company, but notwithstanding, social media or big data can influence people's perception about others big data can influence people's perception of others in general. Then also, big data can also help you to make more accurate business decisions. Of course, when you are equipped with data, it gives you more insight, into customer behavior at a particular point in time. Then in customer segmentation, I used to work in a company that spent about $5 million on customer segmentation. And customer segmentation is very key, it's extremely very important. And the purpose of customer segmentation is that you have huge customers, you should be able to identify your customer. You need to know your customers. If you know your customers, the demography of your customer, the psychographic preferences of those your customers, then you'll be able to know what type of product and services that you should pitch to those customers at any particular point in time. So big data can influence segmentation, segmentation of your customer base. Then at some point also in this course, we are going to be talking about machine learning algorithms like K-means, K-nearest neighbor, data segmentation tools. These are tools that you can use to segment a customer base when you probably don't have a lot of information about such customers. Then it can be very, very relevant in sales and in marketing. You will know the different profile of people to pitch what type of product to at a particular point in time. Then fraud detection in insurance fraud, in banking fraud. Big data have helped a lot of banks to waive off some type of transaction that would have ended up being a fraudulent transaction. Even though some of these guys become smarter at some point and they outsmart the banks eventually. Like last year, I know about 3 banks that they were hit by these fraudsters. Just because of the fact that they become more sophisticated and they could bypass some of those banking firewalls that they have implemented in order to be able to detect fraud. But notwithstanding, big data can also help you to detect fraud as quickly as possible. You know, it can help you to know the patterns at which these fraudsters that they are taking, so that you can plug it or put additional control in order to be able to double check whether a transaction is going to be a fraudulent transaction.
Good afternoon, Blessing.
Hi, good afternoon.
Yes, here. Yes. Please, this table, please, for my education, I just saw that the right-hand part of this table says proportion of business reporting benefits. What does that mean? You know, when you say a better social media influencer marketing, the proportion of business reporting benefits is 61%. I'm trying to understand the value. So to interpret it, I'm trying to interpret it, and I can't interpret it yet. So please help me.
Okay, so this particular chart was sourced from, I think, maybe a Harvard Business Review report, a HBR report, where they interviewed, they did like a survey. They did a survey and they asked some business executive about the impact of big data on their businesses. So they just wanted to know to what extent has big data influenced their business. So based on the responses of those business executives, that's what informed the ranking that is here. It's definitely for your own kind of business. I'm sure that the proportion, or for your own kind of environment, maybe Nigerian market or your own type of business, the ranking is definitely going to be different. So that's why I'm also not focusing attention on the ranking itself, but I'm focusing attention on the different benefits or to what use you can put big data into. So don't pay so much attention to this. This is a report that is captured from some business executives, and this was conducted, I think, sometime in 2017. That dynamics, of course, by now would have changed. But the question is, can big data and the application of it help you to protect in your business? The answer is yes. Can it help you to quantify the risk in your business? Yes. Can it help you to plan better and to forecast your business better? The answer is yes.
Thank you very much. I think the last few sentences you made answered the question I had. That's okay. So what we are hearing is that without big data, so big data helps you convert guesses to actual numbers, more or less, or gives you better, prediction of the future or better understanding of what's happening in your business. I think that's what you've said, that instead of us guessing or using experience or sixth sense, so to say, big data tends to put numbers to the insights or tends to help us with insights to whatever we are seeing from our business in all these areas that you have mentioned here. I think that's what you've said now. So thank you for that answer.
Okay, thanks a lot for that contribution. I think that is a very valid contribution. Data gives you better insights. It makes you make a lot better decisions rather than just relying on maybe innate experience or some innate competencies that you've had before now. So the next question is, what are those different approaches to analyzing big data? what are different approaches to analyzing big data? There are many ways now beyond this. I think I've read materials that had a lot more classifications of the different approaches of big data beyond what you have in this particular material. But based on this curriculum, this is what you have here. So for big data, you may have descriptive analytics. There is the descriptive analytics, which is looking at data from a historical perspective, what has happened in the past. So the business, when your business wants to know what happened to your customers in the past, you want to know the trend, maybe the weather trend in the past. You want to know about what trended on social media last week or this particular week. This week had the inauguration of Mr. Joe Biden. So you want to know what are those keywords there that appeared the most. Those are exploratory data analytics. It's more or less like looking at historical analysis, or that is like descriptive analytics. Then you have predictive analytics. Predictive analytics is trying to determine what will likely happen in the future based on what has happened in the past. So you have a situation where you have you want to know, is it going to rain tomorrow, for instance? You know, it's as simple as it is. That decision can help to drive the business decision you are going to. That information can help you to drive the business decision that you are going to be taking, whether to maybe set up a tent, you know, for your business, or maybe you should just use an open space for your business. So, and then you have predictive analytics, like the example that I showed, dormancy prediction model, where I want to tell, is my customer going to become dormant? If my customer is going to become dormant, then I need to put some intervention in place in order to prevent that customer from drifting into dormancy. So that's another approach to big data. There is the prescriptive analytics, which is the essence. What differentiates that is that you're analyzing data, but the essence of that is to be able to make recommendations on the next best course of action to take, on the outcome, the best next course of action to take on the outcome of that analysis. Then you have behavioral. So I'll give you some things beyond what is inside the syllabus. You have behavioral analytics. So for us in Octave Analytics, one of those things that we do is that we have like what we call the behavioral DNA of a customer. Some other people call it customer 360. So to put that in context, if you work in a bank, for instance, and you want to do the behavioral analytics of the bank's customer. What it means is that you are going to be analyzing for, say, a single customer, for a single customer in that bank. You may want to know everything about that customer's interaction with the bank over a period of, say 3 months. So if you are building something like behavioral analytics, here it's a customer. When did I acquire this customer? So you want to know the date you acquired the customer. You want to know how much time the customer has spent from the moment you acquired the customer till this particular day. You want to be able to answer that question. You want to be able to tell for that same customer how many accounts does the customer have in the bank, because the customer may actually have more than one account in the bank. Okay, what is the frequency of this customer transaction in those 3 months? So in the period of 3 months, how many times have this customer interacted with the bank? How many times have the customer interacted through ATM channel? How many times have the customer interacted through POS channel? How many times has the customer interacted through over-the-counter channel? So when you continue to build that, the table, such data becomes big and it becomes very complex, you know, but what you're capturing on that one single customer is the behavior of that customer. You may be interested in the volume of that customer transaction, the value of the customer transaction, etc., etc. So as you continue to build it, what you're trying to do, it's called behavioral, analytics. That might also even include what you have predicted about the customer. So it might even include a flag. Is this customer going to churn in the next 1 month? Yes or no. That may be part of the behavioral data you have captured on that customer. Then we also have another approach. It has to do with interpreting data. So there are some data that are presented to you that are there are some data that are presented to you. They are not like maybe a name or account number or the volume of transaction or the amount of a customer transaction. They are data that are presented to you in form of a chart. And the Shell example that I gave earlier, the data, I told you that for the project we did with Shell, they gave us data. The data they gave us wasn't the data they gave us were charts. They were huge charts that is showing the subsurface seismic reading that they captured from a site where they are prospecting oil. They were charts, and all we just needed to do was to interpret the data, So that would require another kind of approach. And for the people that are medical doctors that are connected to this particular class, at times when you are working with those medical data sets, what you are trying to look out for, you are trying to look out for patterns. Okay, from this particular image, can I find a pattern that is going to give me a clue whether a patient is going to behave in a particular way or the other? Those are data interpretation, and that is another approach to big data. Please feel free to ask me any question. If you raise up your hand, I will not be able to call you on time because the Microsoft Teams screen is not in focus on my PC. So you can just unmute yourself, and then I will pause once you wish to ask a question. So in terms of application, I've given a lot of applications of big data. So I'm not going to be spending time on this. On your material, of course, you are going to be seeing the different applications of big data in transportation, in education, in travel business, even in the government business. You are going to be seeing different applications of big data. And when you start practicing, if you want access to some of these data platforms, from some of the projects that we have done in the past, we have access to huge repository of big data that we can point you to. So the oil and gas data is somewhere in the cloud. You can point you to that data. There's a transportation data, airline transportation data for all the taxis that are all the taxis in New York. We can point you to that data. For all the airlines in the US or global airline business, we can point you to that data. Then there are other data, banking data that have been anonymized that are also out there on the internet. You can point you to all of these data sets when you start when you set up the virtual learning environment for the practical hands-on session. So please don't hesitate to ask me or any of my colleagues that is going to be handling any of these sessions later on. Now, there's a question here. Let's look at it again. The question is that you are the head of marketing of an organization and you plan to increase your marketing outreach by converting prospective customers into actual customers. Which of the following analytical approach would you consider to adopt best? There could be many ways of approaching this problem. You want to convert a prospective customer to an actual customer. Which of these? Of course, it might require some form of data interpretation. It might require you building some visualization to visualize customer behavior. It might require data collection, but most importantly, in order for you to be able to convert a prospective customer to an actual customer, you need to know the behavior of that customer. So behavioral analytics is the best approach to adopt for this conversion. So if there's a next question, I'm not going to be the one that will answer that next question. Okay. So in terms of top companies that are hiring data scientists, okay. So in Nigeria, the telco guys, the telco guys are a lot more mature when it comes to analytics than any other company. And it's, in fact, the word analytics and big data, okay, the position, maybe manager analytics or yes, manager analytics have been in the telco space for up to like maybe 7 to 5 years now. It's just recently that you see companies are now having a particular job function and they're calling it analytics. It's just recently that banks start adopting maybe manager analytics. You see people that already play in a particular role. They are changing their JD or they are changing their title into senior manager analytics and stuff like that. But those things in 3 years ago, 4 years ago, those things were not in the banks. Insurance companies don't even have. I've not really seen an insurance expert that have the job title of analytics. Maybe I need to check. Maybe I need to check more. But the telco guys actually they are very strong when it comes to analytics. There is a particular telecom company in Nigeria. In sales and distribution, they have a senior manager analytics. In marketing department, they have senior manager analytics. They have about 2 managers analytics. In network department, in network group, they have a manager analytics, you know. And then I now realize that recently a particular bank have also adopted that. Their IT department had a manager analytics. The finance department also had a senior manager business analytics, which is a good thing. So the market is beginning to also realize the essence of analytics, of big data analytics, and they're already creating positions and they're also recruiting people in order to be able to cover that space. So I think it's just a matter of time for the entire market to be able to come to that level of maturity. And by the time they get to that level of maturity and they find you that you're already prepared, you're already qualified, and you have been certified in that area, I want to assure you that when opportunity meets preparation, success is definitely inevitable. But beyond the Nigerian market itself, Google does analytics more than almost any other company. There's Google Analytics. Salesforce does analytics to the point that they even have to go and acquire Tableau just because they needed the visualization tool to be presenting the insight that they generate. You have General Electric, a lot of businesses, even the richest man now, his name is what's the guy's name again? Elon Musk. Elon Musk that is building self-driving cars or that is building cars that run on battery. This type of cars are going to be generating data. So in another 10 to 15 years from now, the data that is generated by this type of vehicles will become another source of data for us to analyze. So when by the time that time comes, a lot of different devices are being designed and they are being positioned in the market that generate all kinds of data. So if you plan to relocate out of Nigeria to Canada, big data and data analytics is always going to be relevant, whether now or whether in the future. So yeah, and the job opportunities, there are different job opportunities for big data analytics. Like you have the data scientists, you have the data analysts. At times people want to know what is the difference between all of this. It's simple, and I want to say, for me, for me, which of these am I? For me, I play in all of these pieces. Whether you are looking for a big data engineer, I can fit into that space. I can help you to set up a big data infrastructure. I can set up a big data platform, set up Hadoop, load data on the platform, migrate data from that platform to another platform, make sure that the platform is available, facilitate people connecting into that platform. That is the job of big data engineers, or what they call big data developers. What they do is that they create the infrastructure, they design and they manage that infrastructure to guarantee that the data is available to the people that are going to be analyzing the data. So that is the job of the developers, or the people that they call data engineers. Then there are some other people that analyze the data, and when they analyze the data, what they are looking for is they are looking out for patterns and relationships in the data set. Maybe they are more or less doing like maybe descriptive analytics. They want to know what has happened in the past, so that they can use that to recommend to the business how the business can function better. Those people they call them data analysts. But you now have the data scientists. The data scientists, what differentiates that data scientist is that these people have the capability to use machine learning algorithms to build predictive models, so they can apply statistical model and machine learning tools on the data in order to be able to predict and to recommend the best course of action to take in a particular scenario. So the data scientists have that additional capability of applying statistical or machine learning tools on the data. That is what makes them data scientists. So you have people that have been analyzing data before data science become very prominent. Banks already have people that are analyzing data. But if you transition from data analyst to become a data scientist, it means that you can actually apply some statistical tool, you can apply some machine learning algorithm on data. So if I give you some data, you can cluster that data using some algorithm to create different groups or different categories of that data set. You can predict some numbers using maybe regression algorithm. So in a nutshell, that is what differentiates data scientists from data analysts and data analysts from a data developer. Which of them sells the more? Which of them earn higher? I cannot say. It depends on the market where you exist. It depends on the company where you are working. It depends on your negotiation power. It depends on your negotiation power. The experience that you have had before coming into that space will determine what you are definitely going to be earning. For my own assessment, I kind of have an idea of who in Nigeria market, who are those people that Nigeria market pay more. And why the Nigeria market is probably paying them more is because that they are scarce. They are scarce. And when there is scarcity, the price goes up. So that one. I'm just going to keep that in the cooler. I'm not going to say that here. But whether anyone pays more, at times it depends on what you are bringing to the table that will determine how much or how the prospective employer is going to position you, or how it's going to rank you. I wish I can get one question or somebody. I want to get some comment around that. At least I've been talking for the past almost 1 hour. We started 2 o'clock on the dot. So any comments around the different careers in data science? Comments, questions? I'm going to ask. Okay, Olivia, can you just make some comments? Tell us something. What do you think about? So where would you want to position yourself? Where do you see yourself in the next 2 to 3 years?
Good afternoon, everyone. To answer Blessing's question, I'm looking towards becoming a data scientist, not analyst, because I think to an extent what I've been doing so far I have an experience with analyzing just more amounts of data. So, but with the explanation that he gave, I think data scientists, um, the one that deals with large amounts of data, like the big data, extremely large data, that's where, because that's where I want to see myself in learning how to code and all those other programming languages. Thank you.
Okay, thanks a lot. Okay, Tani has a comment or a question. So Tani, over to you. Or mute yourself.
Good afternoon, everyone.
Hi.
I have a question. My question is, I've been seeing lots of lessons here right from time, but I want to ask for someone that doesn't have any background knowledge in data science, how would the person try to progress? Because for me now, though, if maybe some months back, I've been trying to have some basic knowledge on data analysis, but I don't have any background knowledge initially. So I want to know how to progress for someone that doesn't have any background knowledge regarding data science or data analysis. Thank you.
Okay, so yeah, thanks, Tani. So I think you're in the right place. So this class is also assuming, this class is also assuming um, that we are not going to be treating people as if okay they've been experts, like okay they know so much, because if you're an expert you probably would not need to be in this class. There are new tools that are going to be introduced in this class, like the R programming language, R Studio, the Hadoop framework. We are not assuming, so we are going to be treating people, even those that are experts, we are going to be treating them as if they are coming into this space for the very first time. So, so to answer your question, I think you're in the right place. All you just need to do is to pay more attention and to be committed. I try to tell people what you need to become an expert is commitment, is time, is that time you need to invest in it. I met a guy at a boot camp sometime in 2016. This guy was an expert, and I asked him, for how long have you been doing this? He said, I just picked up this stuff 6 months ago, but in those 6 months, I gave all of my time to it, and somehow I have transitioned. And that guy was an expert in a particular programming language that is Python. Then I had a lot of projects that I was in. Then I just needed to see some of my projects to this guy, and I told him that, see, the language I needed you to use for this project then was R programming language. The guy said, I'm guessing I don't code R programming language, but I'll give it a shot. And then in another 1 week, he brought the result I was looking for. So for you to be an expert, what you just need to do is to be dedicated. Make sure you have that dedication, and then make sure you have all the learning materials. All the learning materials. You have the virtual learning material set up on your PC. Make sure you have a very good PC. It's very, very important. If you don't have a good PC, I'll just advise you, first of all, disconnect from the class. Go and get a good PC before you come and join the class. Because when we talk about big data, a 2 GB RAM computer may not even be able to load some of these data sets, so, or may not even be able to install some of these tools properly. So those are some of those basic things that you need to get started, and then you put the time and you attend the classes and you are punctual. Thank you. April, over to you.
Okay, so 2 questions. When you were talking about us having good PCs, is there a minimum system requirement that one needs to be able to actively, load the data like you have said, and be able to work seamlessly? That's the first question. Then the second question, I heard you say something about R programming, Python. The question is, along these three titles for data analytics, the data science, the data analyst, and the big data developer. Is programming required for all three of them?
Okay, so in terms of the PC, so the three things are very important when you are considering a good computer. Number one is the RAM size. Number two is the processor speed, and number three is the size of the hard disk. So because it's big data, you must have considerable amount of hard disk space on that computer. So because we are also practicing here, So anything from 1 TB hard disk space will be good enough. 500 gigabyte may also be good enough because it's just we are just practicing in the class. But in a typical corporate organization, of course, we don't recommend anything less than 2 TB. And we can ask for like 4 of those 2 TB hard disk spaces. Then, in terms of RAM size, I have come to see the bigger the RAM, the better your PC performs, and that is basic. For those people that have broad PCs that are less than 8 GB, you just see the PC is just like crawling. You just see you click a button and then you have to wait. You have to wait a long time for the data to load. So if you have a PC that is less than 8 GB RAM, I would recommend that you upgrade your PC. So that minimum RAM size is about 8 GB. And I think there's a document by the time we try to set up the virtual learning environment on your PC, there's a document that has all those minimum PC requirements for you to be able to set up the big data platform on your computer and to be able to run those big data analysis on your computer. So the more the RAM size, the better your PC. A guy brought a PC that has a 20 gig RAM size. As you are clicking, it's responding almost immediately. As you are submitting your query, the data is coming out almost immediately. The guy was working in Obat Oil, so it was this company that gave him that computer. Solid, very solid PC, and the hard disk was a solid state hard disk drive. So those solid state hard disk drive, they perform a lot better. Processor speed, of course. Processor speed. The latest computers that are coming now, their processor speed is fairly good enough. So processor speed from 1.9 gigahertz. If it's a dual core processor or if it's a Core i7, will be fine, or Core i5 will also be good. Now, in terms of whether programming skill is required, yes, for all, it is required. Programming skill is required. So if you're analyzing data, basic analysis, you want to know how much the business generated last month, for instance, and you're not using Excel to do the analysis because Excel cannot load that data. You need a tool. So you are loading it into a database, the data into a database or into a big data platform like HDFS, for instance. How do you query the data to be able to aggregate it in a way that is presentable? You need a programming tool. So R has those functionality, those analytics function or data analysis manipulation function. So it has a huge library that can facilitate those type of analysis. So for data analysis, you need programming. For data science, if you want to build machine learning algorithm, you want to be able to predict based on what has happened in the past, what will happen in the future. You need those algorithms themselves. They are coded with a programming language, whether it is Python or R. So you need to understand how those programming language, how they function, and you need to be able to also write them themselves so that you know which programming language do you need to call in order to be able to do a particular prediction. So you need that. Then for the data developers, yes, their job is not just to install. they're not just installing the platform, they're not just installing the platform. They also need to like aggregate data. They also need to do data migration. So you want to move data from an Oracle database to, like, let's say a Hadoop Hive or an Apache Hive or a HBase, for instance. To do that data migration, you might need to write some code. It may just be 5 lines of code, but you need to understand what codes exactly do you need to write and how you need to write it. You might need to call some function, you might need to call some libraries. What do you need to make reference to in order to call those libraries? Those are the things you need to know that require some programming skills. So for all the three, you need to learn programming. You need to learn programming. But of course, don't be scared. What you need to learn will be taught in this class. Okay, let me see. Send other person raising his hand. Okay, Juice 6 is raising up his hand. Please, I can take your question now. Tani, please lower your hand.
Okay. Good afternoon, Mr. Blessing.
Hi. Please, what's your name?
Ernest.
Ernest. Okay. So your name looks a bit different here.
Okay. Quick one. My system is a 4 gig RAM, then 500 gig ROM. Am I good to go?
You need to upgrade the RAM size.
To like 1 terabyte.
You need to upgrade it to like the RAM size.
So for now, can I tag along or?
Of course, now, yeah, that does not stop you from attending the class now. Of course, you can definitely attend the class. It's only when you start doing the practical stuff, it's when you start installing the learning materials on your PC, that is when you start only encountering issues when the RAM size is not. Of course, you can definitely tag along. Why not?
So you say 8 gig RAM, then 1 terabyte.
8 gig RAM is fine, is good enough. 8 gig RAM is good enough. The 500 gigabyte space that you have is also good enough.
Okay. Another question. To what extent are we going to use MATLAB?
No, MATLAB is out of scope for this class.
Okay, but is it also a tool in data analytics?
Yes, it is. MATLAB also has some functions and libraries for data analysis, but it's not MATLAB that we are. MATLAB is completely out of scope for this class, but it has functionalities for data analysis, although it's limited in some ways, but it has some functionalities that can analyze it and do some predictions.
Sorry for this question. I did not join early enough. What was the duration of the program?
It's 12 weeks.
12 weeks.
Yes.
All right, sir. I'm done. Thank you.
Okay, thanks a lot. So let's look at some of those keys that you require. So the programming skill, we've already said that. It could be Python, it could be R, it could be Java, it could be MATLAB, it could be SQL. So if you're already conversant with SQL, if you're conversant with any programming language, then I'll tell you good luck, because you find every other thing will kind of be a lot more easy for you, because programming languages to a very large extent, they are similar. It's just that the syntax is what differs, So if you need to learn the syntax for Python or the syntax for R, once you master the syntax, then you become an expert automatically. So in this class, for this class, it's R programming language that we are going to be using, and is generally accepted as one of the data analytics or data science programming languages. Then also, we're also at the early stages of this class. We are going to be talking about Hadoop, the Hadoop framework, the Apache Hive, and MapReduce. Those are part of the element of this particular course, and I'm sure that you find that very interesting by the time we start talking about all of that. The guys that are the data engineering, the guys doing data engineering are also going to find this a lot more interesting because they are going to be going deep into the Hadoop framework, the Hive and the MapReduce elements of big data or big data of big data. So I hope you would also find all of that interesting. Then we'll also be talking about things like machine learning, algorithms, natural language, NLP, natural language processing, the concept of predictive modeling, the different type of predictive modeling algorithms that are available. You probably have heard me talk about things like maybe classification algorithms like decision tree and random forest, or maybe regression algorithm like linear regression, or maybe a clustering algorithm like k-means, and so on and so forth. All of those concepts are part of the element of this particular course, and by the end of the course, of course, you should be able to like engage anybody at a professional level in on some of those topics. Then at some point, of course, we will be talking about statistical analysis, mean, median, mode, standard deviation, and stuff like that, and how you can call some R function to be able to perform statistical analysis. Then for soft, those are the technical skills that you need. For soft skills, it's also very important you have a solid written and verbal communication skills. It's very important because, again, if you are working in a company and you have to do a report for the chief commercial officer or the chief operating officer or the chief executive officer, your report is not, you're not going to be showing him your R code, the R code that you wrote, or the SQL code that you wrote. You're not going to be telling him a decision tree or machine or random forest. No, that's not what you're going to be saying to him. You are going to be presenting to that person in verbal or in a written. You are going to be writing reports, to present the outcome of your whatever model or analysis that you have done. So in that case, you need to be able to master some of those soft skills because it is a selling point. The people that have mastered those skills, they, even when they are not very technically sound, they usually are better favored in organizations from what I have learned. So don't just be a technical person, or also learn some soft skill. It's going to really help you as a data scientist. Then of course, you also need to be able to learn how to query databases, how to convince senior management, how to advise senior management on you have an idea or the data is telling you something. You need to have the ability to advise senior management, how to present yourself to be able to advise senior management. And you also need to, this is extremely very important. This is extremely very important for any data scientist or any data analyst or even a data engineer that is at the back end. It's extremely very important to understand how the business works. So if you are a data scientist with a bank, by the time you move into a telco space, I can tell you, you might be lost. You might be lost completely because what you have always known to be a phone number, when you go to a telco space, they might be calling it MSISDN. And then if you wonder what is MSISDN, if you are in telco, what you have always known as account number, by the time you go to a banking space, they are calling it for ACID, or they are calling it ACID. And then you are lost. What is ACID? That ACID is just account ID. So understanding of the business and how the business works. So if you are supporting a loan business, for instance, a fintech that issues loans to people, you need to understand how the business works. That would help you to be able to build models or how to be able to analyze data properly or to build data platform that can significantly help the business that you are supporting. So understanding of the business is it's extremely very, very important. So this question, so who is going to take this question for us? I'm going to call Temilade. Temilade, so the question on the screen, can you just read out the question and explain why, what the answer is and why you are choosing what the answer is? So Temi.
Hi, okay.
Hi Temi.
I'm reading the question. I'll provide an answer. Let me mute because there's background noise.
Okay.
So I'll choose design, create, manage, and interpret large data sets. That's the third option.
Okay. Thank you. So can you mute your microphone?
Sorry.
Okay, so the question is that Sam is seeking a career as a data scientist. So which of these is a key responsibility of a data? Okay, he's seeking a career as a data analyst, and which of these is a key responsibility of a data analyst? Number one is to determine what data means and recommend which ways to search the data. The second one is to specializes in collecting data from different sources and organizing it in suitable ways or in suitable formats and making analysis. Number three is to design, create, and manage and interpret large data sets to achieve business goals. And number four is to develop codes and images to automate data reports. Okay, so when you look at it, I know for people who have been data analysts in some organization, they will, when they look through the whole four, they can say, oh, I think I do a little bit of, I write codes, I interpret data, I organize it in some suitable format, and I make analysis, and then so even that number one, the first option is completely out of it. So that one is completely out of it. So the answer is either going to be B or C or D. So it depends on what you do in your organization. So the answer to this is actually subjective. It's not like you can actually be collecting. There are data analysts in companies whose job is to make sure that the data is available and they organize it in a suitable format and they analyze the data. That is the B option. There are data analysts who design and create and manage and interpret large data sets to achieve some business goal. But that looks a lot more like what the engineers do. So it's the data engineers that their job would take towards the design and create and manage large data sets, and they are doing that in order to achieve some data goals. So that looks more like what the data engineers would do, the design and the creating and the managing. They don't interpret it. The data engineers also develop codes, and in some cases they can also write automated queries in order to be able to they write some queries to automate some reports to make the data available automatically. So Temi is saying C, I'm saying B, but it can be something else for somebody else. It's a subjective, it's not necessarily an objective question. Okay, so let's move on. Future of big data. Yeah, so big data, it's always going to be in vogue for the next 5 years, for the next 10 years. I can assure you, with the new type of technologies that are coming up, with the trends that are coming up, that are out there, I can assure you that big data is always going to be in vogue. So let's quickly do a summary before we go to technologies of handling big data. So what we have discussed between yesterday and today is what big data is, the elements of big data, what exactly are those things that define big data, um, the what are the uses to which you can put data into. Those are some things that we discussed. What are the different sectors or industries for which big data can be applied? What are the different sources where you can acquire big data from? And what are the different types of big data? It can be structured, unstructured, or semi-structured. We also said that big data can be sourced from social media or from it can be social data, it could be machine data, it could also be transactional data. Then we also mentioned that the different approaches for analyzing big data could be predictive analytics, could be data interpretation, it could be behavioral analytics, it could be um, descriptive analytics, it could be um, prescriptive analytics, where you make recommendations for the next best course of action. Then we also mentioned, um, okay, so I think that it's about the end of that introduction. So let's look at the technologies for handling big data. And this is a very very interesting part, the technologies for handling big data. So we have another 30 minutes to end the class. Please, if you
Sorry,
have
someone's hand is up. Lesson.
Oh, caller, yeah, caller, please go on.
Please, my question is, there are a lot of, technical skills and soft skills. So the soft skills are required for everybody that wants to communicate and interact with other people. The technological skills, I saw Python, R, MATLAB, Pig, etc. Now, the question is, would we be introduced to all of them, or there are a few of them that will be introduced to in the course of this few months of training?
So what you saw there is programming skills. Under the technical skills, what you saw there is programming skills like R, like Python, like Java. It does not mean that you need to know everything all at once. No, you just need to know one of them. There are data analysts or data scientists that their competency lies in the area of SQL. What they've been doing for years now is just SQL. That does not disqualify them from being a data analyst, and that doesn't mean they don't have technical competence. So it's not going to be all of those. It's not going to be all of those. For this class, as I said before, it's going to be the R programming language. It's going to be the core programming tool that we are going to be using to communicate. It's a language. It's a tool for communication. So that is going to be the language we are going to be using for this particular class. So at least you once you know R, you can pick up the rest by yourself. Especially for those that don't know how to program. For those that already have some background in programming, I think R is going to be extremely very easy for you. It's an interpreted programming language. It's not a compiled programming language. So and it does not execute at runtime. So it executes from interpreter. So interpreter, it executes one line at a time. So you write your query, you click enter, and then it executes almost immediately. So you're definitely going to find our programming language very interesting. But we are not teaching, we don't have that space and time to teach all of those programming language. And I think also, yeah, so let me keep it at that. Yeah.
Thank you.
You're welcome, Kola. So we are looking at the technologies of handling big data. And here we are going to be talking about distributed computing. This is a little bit technical, but it's good it's good, you know it, so that at least you'll be able to interact with anybody at any level, you know, especially those that are computer scientists that also have significant amount of training in the areas of computing. You will be able to relate with these people whenever you have that opportunity of engaging them. So you have, we are going to be talking about distributed computing. We are going to be talking about the Hadoop distributed computing environment, the Hadoop architecture, the Hadoop framework. We are going to be talking about it. We will also be talking about cloud computing and what cloud computing is good for. We'll be looking at it and why cloud computing is good for big data analytics. And then we're also going to be talking about in-memory computing. These are more or less like the latest technologies for handling big data. You know, so we'll be describing some of these. So please fasten your seatbelt as we proceed. So we are starting with the concept of distributed computing. And the best way I can explain this, the best way I explain this to people is by just telling a very simple story, or I just will paint a scenario. So in computing, generally, there are two problems that we try to solve in computing. And number one problem is we want to solve the problem of space. So because the space that is available to computer is always limited. Remember when we're talking about PC, we're talking about RAM size. Somebody said that he has a 4 gig. We said that maybe you should upgrade it to 8 gig. He also said he has 500 gigabyte RAM. That is space. So computing tries to manage the space that is available for it to perform any kind of operation it needs to perform. Then the other resource that we also try to manage is time. So something needs to be done. Is it possible to do it in the shortest possible amount of time? Those are the two problems we try to solve in computing. So also when you're working in a company and you're analyzing data, you want to get your results out. At times the business cannot afford that you should take like 1 week to give them some result. They want the result, and they want that result almost like at the time they are asking that question. So there are technologies that have now been developed to make sure that data is analyzed faster and is analyzed more efficiently. And when we talk about more efficiently, we are talking about the resources that is required in order to analyze the data. And we are talking about faster, we are talking about the speed of execution of that data. So that led to the development of the concept of distributed computing, where rather than the traditional computing technology, which is like batch process of computing or first come first serve, in this case things are done a lot faster. And the second thing has to do with having computers or having computing resources connected within a network, and a task or a computing task is distributed across those resources. So how many of us are in this class? Let me quickly do a quick count. In this class, you have 9, 10, 11 people in this class. So we have a big data that we want to crunch. So I mentioned the share data, and the share data had like maybe 7 files, and each of those files, they are like each of those files is about 300 gigabytes. So 7 files is about 2 point something terabytes. So only my computer cannot even support 2 point something terabyte. My computer is just say 1 terabyte, or say 500 MB. Another person's phone is 500 MB. But for all of 11 of us, at the end of the day, maybe we can gather like maybe 7 terabytes among ourselves. But the task that we need to perform, it only requires about maybe 3 terabytes. So is it possible for us to connect our computers together in a way that this data that we want to get from Shell, we are going to distribute it among all of our computers so that it does not weigh a single computer down by the time you start executing or by the time you start analyzing that data? That is the concept of this. That was what the developers of distributed computing, that was what they had on their mind. Let me break it down in another way. I love this example. So you have 1,000 people. They want to go to, you want to take them from Lagos to Ibadan. 1,000 people. So what options do you have? The option you have is that you can put them in a car. Okay, all of them cannot occupy a single car, but you have a car. So you take the first set to Ibadan with your car. You come back to take the next set until you take the last 1,000 person to Ibadan. So you keep going back and forth, keep going back and forth, keep going back and forth. So that is one way you can solve the problem. Another way you can solve the problem is, okay, 1,000 people need to go to Ibadan. So if a car can take 5 people, so is it possible for me to get about 200 cars that will take this 1,000 people to Ibadan? If you successfully find 200 cars, it means that in 3 hours, you can solve that problem in 3 hours. So within 3 hours, you can put all of those 1,000 people in those 200 different cars, and then you drive the car to Ibadan, and then in 3 hours, the problem is solved. Another way you can decide to solve the problem is, okay, maybe you should just put them on a train. You can put all of them on a train that has capacity to take 1,000 people, and then the train will drag itself and those 1,000 people, and then it will drag them to Ibadan, and then the problem is solved. So those are 3 different ways of solving problems. So now, the concept of distributed computing is similar to you distributing those 1,000 people on 200 different cars. So can we find, like, there are 11 of us in this class, can we connect our computers together within a network in such a way that when you have a big data job that would, for lack of a better word, that will kill one single computer, can we have that job distributed among these 11 computers so that the impact and the computing resources will be shared among all of those 11 computers so that the job can be done a lot faster? That is exactly what the problem that distributed computing is trying to solve, to get job done faster and to get it done in a much more efficient way. Now, for you to be able to now perform very complex computation, the processing power of all of these different computers that are connected within the network, it's aggregated, it's aggregated in a way that it enhances the computing. So for the car example that I gave, you bring 200 cars, so you can share the resources of those 200 cars to convey 1,000 people to Ibadan. So if a car would have done that job, the car would have gone to Ibadan, spent 3 hours, and come back again and spend another 3 hours again to take another 5 people and come back again. So you imagine how much time it will take one car to take 1,000 people. But if we bring 200 cars together, that means we can get the job done a lot faster. So you have a job, that job is broken down into subtasks, and each subtask is distributed to each of the computing resources that is available, and that way the job is done. That is distributed computing. Parallel computing will be the trained solution. So the trained solution is to say, okay, these 1,000 people, I want to distribute them on a train, in different coaches in a train, and then the train will just take all of them from Lagos to Ibadan. So if the train takes 4 hours or 6 hours to get to Ibadan, at least it has gotten the job done, and it did it in a better way. So you are employing more processing power. For the computer, you are employing more processing power in order to be able to solve that problem. So for parallel computing, what you are trying to leverage is, can I employ more processing power in order to be able to solve a problem? For distributed computing, what you are trying to do is to aggregate resources together. They may not necessarily be more processing power. It may even be as much power as what you had before, but you are bringing all of them together in a way that will help you to get a job done faster. So the job that you have at hand, you break it down into smaller tasks, and then you distribute it among those commodity resources, and then they get it done, and then you combine the results again. So I'll give you an example. Say I want to search for food on Google. I'm searching on Google food because I like food. Food on Google. So it returned 7.4 billion results in 0.73 seconds. How can that be? How possible is that you are searching for food, and the result that it returned 7.4 billion, about 7.5 billion results in 0.73 seconds? How is this possible? The fact is that as I submitted my query, what Google did was that Google itself does not have the answer. Google sent this query to all of the computers within its network. And then all of those computers within its network, they returned the result. And Google combined the result and showed me, okay, this is the count of all the results that I returned. And it did this within 0.73 seconds. If all of these 7.5 million records, if they were on a single computer, in fact, I'm sure that it's probably going to take several days for Google to be able to do all of this count and for it to be able to return all of that result. So the concept of distributed computation tries to divide the job among many computers, while parallel computing tries to employ more processing power in order to solve the problem. So we have a big data problem. There are two ways we can solve it. Or there are two general concepts or general approach to solving those big data problems. One way would be, okay, let's break the job down into smaller tasks and get other resources to help us to solve the problem. The other way would be, okay, let's go and employ more computing power. Let's go and employ more firepower in order to be able to solve this particular problem. Those that study computer science will be able to relate with this a lot more. But it's part of our everyday life. When you have a problem too, you probably want to, if one person is going to do a job in 1 week, in 7 days, that means 7 people can get the job done in 1 day. Is the concept that is applied to, is that same thinking that is applied to computing, to distributed computing. And for parallel computing, it's okay. If one average man can get the job done in, maybe can pull a car, maybe in 2 hours. Maybe if we get somebody that is better fed, that have more power, maybe he will be able to pull that same car for a shorter period of time. That is parallel computing. So to differentiate the two, distributed computing is a collection of independent computers that are connected together, while parallel computing has multiple processors. It's like a single system. It's just like a single computer that have multiple processors attached to it. The distributed computing, the computers in distributed computing, they are coordinated in a way that a job is split among them, and it's designed in such a way that they are autonomous. I think the word is autonomous. They are autonomous, so they are independent. Even though they are interconnected, they are independent, and the job that you have is assigned to each of those independent autonomous system within the network. So they have separate memory space, they have separate processor, they have separate hard disk space. So they are autonomous. So you can disconnect them from the network, and then it's still going to continue to the distributed system is still going to continue to be operating. So if, for instance, the 200 cars, if one of those cars break down, it does not stop the job of taking 1,000 people from Lagos to Ibadan. What it will mean is that at the point at which it broke down, we can decide to say, okay, take one person from the car that broke down, attach the person to any of those any of the cars that's not broken down, you know. While for parallel systems, they share common memory. Even though there are multiple processors, they share common memory. And finally, for distributed computing, the computers, they are loosely connected, and they can access data and resources that are located remotely. But for parallel systems, they are not loosely connected, they are tightly connected. Another example, I'll give you another example. So look at an aeroplane. An aeroplane that has a twin engine can be a good example of a parallel system. So it's like more processing power, while the aeroplane fuselage where people sit is like the memory of that computer or of the aeroplane. So if you have a job of taking 1,000 people from Lagos to Ibadan, for instance, so you can go and employ a more firepower. You can go and get an aeroplane that has twin engine. So, and it can, with the advantage of that twin engine, it can move a lot faster. And then maybe it has capacity to take 200 people at a time. You take those 200 people, it will take them to Ibadan and come back again. So instead of it going like 200 times, it could just go 5 times, and it goes very fast. And at the end of the day, it will succeed in delivering the 200 people, the 1,000 people to Ibadan. I hope I have not confused you. So I'm going to throw it to the house. I need someone to explain what I have said in a different way. Who am I going to call? Who have I not called? You have, let me see. Daniel, you've been in the class. So for what I have said, can you say it in a different way, just for me to see whether you grab the concept? No, Dorcas. Daniel is not responding. Dorcas, I've not heard you say anything today. So can you say what I have said in a different way, just to be able to see whether you got the concept of distributed computing and parallel computing, and why it is needed in solving big data problem? Is Dorcas on the call? I hope I'm not the only one on this call. So is there anybody that can hear me that can just help to paraphrase what I have said?
I can hear you.
Okay, great.
I can hear you.
Okay, great. So I need Ekwi, can you like say what I have said in a different way?
Okay, let me give it a shot. Okay, so basically what I understood from what you have said is I can liken distributed system to division of labor, for instance, whereby if you have, let's say we need to make some fancy kind of rice. Now let me use food as an example. And you know, you need to cut onions, you need to blend pepper, you need to, the bottom line is we want a fancy dish, right? And for us to be able to do all of this, it requires a lot of effort and a lot of work. So, but basically one person is blending pepper, one person is cutting onions, another person is boiling water. That is like a distributed system, right? But in terms of parallel system, if we still want to liken it to this our fancy dish, is we could say that we would have to do everything at the same time. So we might be two people doing it, but you know, everything we need to get the dish ready, we do together. I don't know if that's explanatory enough, but basically what you said is for distributed, the systems, the task is shared among a lot of processors so that our results come back to us faster. But in terms of parallel, it could be just one system with maybe greater kind of speed or greater processing power, and then we get our results ready. That's my understanding.
Okay, thank you. So that is extremely encouraging for me. The last two sentences that you made were spot on. You know, so you simply got the concept for distributed computing. The job is shared among independent but interconnected computing systems. You know, even though each of those systems they are autonomous, they can exist independent of the other ones, but the job is shared among them. While for parallel computing, you just need to like hire more processing power, but the memory itself is shared. Opeole Popola has some comments. Let's take her comments.
It's just like a question or something. So I want to clarify something in terms of timing and in terms of space. Can you hear me, sir?
Yes, very well.
In terms of timing and space, it's not clear to me whether they're still going to achieve the same objectives at the same time in terms of timing and space. I don't know if you get my point. For the distributed system.
Okay, so thank you. I like that question, and so let's look at it this way. So let's say 1,000 people. We want to take 1,000 people to Ibadan. We want to take 1,000 people to Ibadan, and let's assume that it takes 2 hours to go from Lagos to Ibadan. If there is no traffic, it takes 2 hours. So one solution is that we have only one single car. So the 1,000 people is a big data problem. So one solution is that we have only one car to take those 1,000 people to Ibadan. So you imagine how many times that one car will have to go to Ibadan and come back and go to Ibadan and come back and go to Ibadan and come back in order to be able to solve the problem, the big data problem. So that is one solution. There is a distributed computing solution. The distributed computing solution will have to bring autonomous, independent systems to solve this problem. So let's say we go and fetch 200 cars to take those 1,000 people to Ibadan. So ordinarily, it takes 2 hours for a car to go to Ibadan, but this time around, because there is now an overhead of coordinating the people, there are more cars that are on the road. Maybe at the end of the day, maybe we succeed in taking the 1,000 people to Ibadan in 2 hours and 30 minutes. Or maybe one car broke down on the road. So at the end of the day, it took us maybe 3 hours to take the last 1,000 person on the road. But note that we have deployed more computing resources. We have deployed more autonomous, independent resources in order to solve that big data problem. So that is the second solution. Then the third solution is, so now in the second solution, we're able to solve it in 3 hours. In the first solution, that one will even take like, it will take like maybe 2,000 hours or maybe 4,000 hours to solve the problem. Then another solution is, let's say we want to get an aeroplane. So because aeroplane has more firepower, has twin engine, can go faster. So aeroplane can go from Lagos to Ibadan in 30 minutes. But the capacity for that aeroplane, the memory is limited, even though it has more computing power. The memory is limited. So aeroplane can only take 200 people at a time. So it means that the aeroplane will have to go like five times. So it took the aeroplane to go 30 minutes to Ibadan, another 30 minutes to come back to pick the second batch, and goes again and comes back again and goes again and comes back again. So at the end of the day, maybe the aeroplane will spend like 3 hours plus some extra weight here and there. Maybe it took the aeroplane 4 hours to get the job done. But you can see that the aeroplane has also solved the problem in a more efficient way than the way only a single car would have solved that problem. A single car would have solved that problem in about 4,000 hours, because if the single car goes to Ibadan and took 2 hours, it takes another 2 hours to come and pick another set of 5 people and go to Ibadan. So by the time you calculate all of that, a single car will take like 4,000 hours, 200 cars will take like maybe 3 hours. One single aeroplane will take like how many hours? Maybe like 6 hours to solve the problem. So it may not take exactly the same amount of time to solve the problem, but some of them will solve it in a more efficient way. Some of them will solve it faster than the other. That is the whole concept around disparate computing and parallel computing. I'll be glad to take more questions on that or more comments on that. Does that answer your question, Nakbe?
Yeah, good. I like that. Thank you.
Yeah. Okay, so Juice 6, please, you raise your hand. Please go on and ask your question.
Okay. For me, I think each one has its pros and cons. One that is very glaring is for the distributed system. Even if a system shuts down or goes or packs up, the process can continue running. But I'm not sure about the parallel system. Let's say a processor goes bad. Will the process continue running?
So the advantage, what parallel processing is bringing more processing power. And because it's bringing more processing power, it's possible that a plane is flying and one of the two engines fails while it's in flight. Yeah, if one of the two engines fails, it will still continue to fly. The job does not get stopped because one engine fails. It's only that maybe the aeroplane will now fly slower than it will ordinarily fly. You understand? But the fact that, number one, it has capacity to move more people, because the memory space is bigger and it has more processing power. So it's still going to be a much more efficient solution and a faster solution compared to when the only choice you have or the only option you have is only one car to take 1,000 people.
All right.
Okay, thanks, ladies and gentlemen. Thank you for your contribution. It's been a very it's been a lively and interactive class. We are going to stop on this note today. Hope to see you next week Friday. And this session is recorded and is going to be available to you. The class administrator is going to be sharing the link to this class so that in case you want to go over the class again. For those that have paid, I think this weekend we are going, or maybe latest on Monday, we'll start distributing the training kit to everyone that has paid. If you can take some time to come into the office during the week, we can also help you to set up the virtual learning environment on your PC so that you can practice ahead of the class, and you can also learn independent of us, at your own spare time. Please, if you have any comments, please feel free, ask me questions. I'll be glad to take your questions. Okay, ladies and gentlemen, in the absence of any other question, thank you very much. Do have a great weekend. Bye.
Thank you, Blessing. Bye. Thank you, Blessing.
Bye, Ekwe. Bye, Olivia. Bye, Gwen, Daniel, Tani, Ola.
Bye.
Bye. And Dorcas. Yeah, bye. Ahmed. Bye.